Welcome to the Continuous Delivery Podcast. My name is Zarar, and I'm joined today by Max Tykhenko, the security architect from IBM. Not the security architect, but a security architect from IBM. And Max and I have also worked previously together in EPAM. So welcome, Max.
Hi everyone. Hi Zarar. My name is Max, and right now I'm security architect at IBM, but I have a big history of working in software engineering. So it's like, I guess, 19 years, right? Majority of them is actually building the software, right? Technical design and,
Yeah, for sure. I mean, you were the solution architect on projects that.
I see. Last years, my primary focus is security. But previously, I was actually involved in all the aspects, right? All different qualities, performance, and like. But now, definitely, security is my main area of it.
So let's talk about security a little bit because it's something that people don't talk about enough. But lately, with distributed computing going on, with a lot of IoTs in the field, the sort of attack surface area has increased, and more people are paying attention to it. Especially whenever you have a security issue, usually hit the news. So that's never really good. So just let's start off with talking about like attack surfaces in general. Like, so over the last 10 years or so, how has that landscape changed? Like, if you're a security architect over the last, say, 5 years, what are you thinking about that previous security architects, previous to that, did not necessarily have to worry about as much as a security architect has to worry about in the last 5 years?
Yeah, sure. Probably let's start with maybe defining the term attack surface, right? So it's basically the sum of all the points, right, that any unauthorized user can entry, right, to use into your system, use as entry to your system to get out of your data, maybe get access to your system, right? And in the recent decade, right, so we get many new waves of in software development, right? New technologies and so on. And we are seeing that, like, for example, the huge volume of cloud adoption, right? So we used to sit in our locked on-premise, right, data centers, right? We have control over this, right? Now we are starting big modernization journeys, and the customers keep and the users, right, and the companies who develop software, they move everything to the cloud, and so rapidly that nobody properly considers like what should be the right measures, right, for doing this, what kind of data they are moving there, and so on, right? Also the skill gap, right, sometimes is the concern because the direction, for example, it's flexible, it's easier to develop software for the cloud, let's go there, but people should probably first maybe gain some skills, right, of doing this in the right way. And maybe in the recent years, right, we have this huge spike of AI, right? Models, LLMs in particular right now, right? So this is another kind of addition to the surface, right, that can be used for the malicious users to attack enterprises, to steal data, or maybe bring some damage to the reputation in general, right? Because they are widely adopted, they are also considered to be really solution for many problems, right? Customer support, other stuff, right? And they also widely adopted, and they also pose the risk, security risk, right? And it's not always considered properly. Before, excitement goes before consideration, right? Whether we should do this and how we should do this to ensure that it's secure enough. You are on mute, I guess, for some reason.
Yeah, sorry. I also feel like the sort of before, security was something that was delegated to a particular group in the company, or there was a certain team that had to worry about security. And I find now more that security is not just if you do that, that's basically setting yourself up for disaster, because you can no longer sort of offload security into a particular group. So talk a little bit about how maybe the developer mindset needs to change or has changed over the last few years when we're talking about security? Because like basically we've democratized security a little bit more. And how has that changed what the developer skill set should be?
Yeah, definitely you are right. So like it used to be like we have security department or security team who takes care of everything, and they kind of like bad guys come in at the very end of the project when everyone thinks that we are done, green lights, and they say, okay, stop guys, right? We'll do some pen testing, whatever, and there is a list of vulnerabilities or concerns we have, go and address. And it's like a showstopper, right? But like with the rising volume of the security threats and so on, and security teams also have many tools now, right? They get these alerts and so on, so they cannot scale basically to address all the concerns. And also, like when the project is getting signed off, they cannot like process many projects, onboard them, provide the feedback, and then revalidate the findings, right? So that's why here I also see the same trend like as it used to be previously, which resulted in DevOps practice, right? Where developers before DevOps were like used to build software, throw over the fence, and somebody will deploy and run it. Then the guys who try to deploy and run it failed and say, guys, like we don't know what you need to make it run successfully. Any like memory, CPU requirements, whatever. Then it resulted into like shifting this kind of left, right, and building this practice. Same happens with security right now. So basically, also like probably everyone heard the DevSecOps, right, practice and framework, right, where you try to adopt the practices and security, like tools and measures early in the cycle of development to avoid big surprises at the end, right, and also trying to educate developers like about like kind of what should be also considered during development, like how they need to choose libraries they use, maybe frameworks, whatever, right, to actually eliminate this kind of risks at the very end, right?
Yeah, and I'd also say like double clicking on that point you made about about libraries. Like I think before, I remember when open source was looked at as, oh my God, you can't use that in a project. We're an enterprise. You can't even download this like JS library. You have to get like 4 approvals. And now organizations have basically relaxed that concern. If you want a Java library, or if you want something from Node or whatever, you can get it pretty right away. But that also opens up a lot of attack surfaces.
It's additional attack surface, right? And we had multiple problems, right? In the recent past, right? Log4j, widely adopted library for Java, which actually provided an opportunity for attackers to execute their code on the application server. And it was huge boom. All the customers, like everyone in the world, was like, oh my God, what we should do, right? Any mitigations, like let's scan all our projects, who uses this and so on, why? And also another point that I have here was the wide adoption of libraries, and they provide really ease to developers to quickly develop software and ship it, right? At the same time, I'm comparing this experience to myself like 19 years ago, when, for example, while building the app, I had to specifically define what I expose, like any endpoint. I had to like register servlet, right, or like write GSP and so on. Right now, we just throw Spring library, one library to a project, and actually it spins up everything. You put one like annotation, it works, right? But under the hood, it also exposes additional endpoints for health checks, assuming you will run this maybe in the Kubernetes, right? Or other stuff you don't even know about, right? And by default, they are open, and nobody knows, right? And if the attackers know that some particular vulnerability in such endpoints, they can go and use them, right? And you don't even know that they exist, right? Because by default, you just throw through the library, you don't even know how it works under the hood, right? For you, it's just a piece of annotation in your code.
And it's also that I feel the how frequently new versions of libraries are released is also increasing. So, for example, I mean, if you use Next.js or something like that, or if you use a popular JavaScript library, there's always new patch versions being released. Whether it be a minor or usually a minor patch is released, and those are usually security fixes. So it feels like the more libraries you need, it's a balance between, because you need those libraries because you don't want to write your own. I don't know, like email validation or whatever, right?
Reinvent the wheel, right? Nobody wants to reinvent the wheel. You want to build the business code, but like
exactly.
stay
But
away
however,
from, like,
while trying to reuse and trying to focus on business value, we also sort of open up ourselves to a lot of maintenance work, because you have to keep these libraries up to date. Any patterns that you can share with maybe development teams who maybe have like a bunch of open source libraries and have to kind of constantly monitor them? Like one example that I found is GitHub has this little bot called Dependabot, which will basically give you a patched version of it'll basically give you create you a PR with an updated version, which is like, I don't know, 10% of the work, right? I mean, anybody can create a PR automatically. But any practices that, or any team models that you find where developers or teams can actually keep up with the latest versions, like how do you see that happening in the industry? Do you like take a sprint out and you start worrying about past versions, or
yeah, I mean, like, it's really hard to do in one shot, right? And especially with the currency, because if you wait too long, right, it definitely becomes like, a snowball that becomes in there like an avalanche, right? And you have to stop the world to make this upgrade, right? But if you do this like on regular basis in small portions, it helps. That's why in your build process, right, there should be there are basically libraries that can help you analyze for example, the CVE, this vulnerability rate announcements. It can analyze your dependencies in the project and tell you like warnings or critical like stuff, right? Like it's kind of static code analysis, basically, right? That can highlight the risk, and you can kind of stop your build and consider maybe upgrade, right? If you want. So that's what I used also in my project in the past, and it helped me also like path in the like pen test, right? Because pen test team they change, right? And the one like third party vendor is hired, they run the test, they provide you a list, and then you need to fix, you need to ensure that nobody brings the problem back, right? That's why the only like way to solve this, you need to introduce some like step in your build process that will fail the build, right? If somebody violates the rules, right? That's why, there are tools and developers definitely should use them.
So you talked about pen testing a couple times, and that's always been a source of contention. I think when we worked together, it was a source of contention. And
every year new team and a new set of stats. They are looking all from different angles, and like, you think that you are done, and then the next year you are not done because new team comes with own rules and.
Right. So has there been any progress made on shifting something like pen testing to the left? Because from what I can tell, whether it be tools like Koalas or whatever IBM's latest product offering is, whatever it is, they still seem to happen like in a later stage in the pipeline. Is there something that any tooling or any practices that developers can use where they can catch sort of basically do pen testing on local host? Because ultimately you want to validate as much as possible at local host before you even commit your code. But pen testing has historically been well after deployment. Forget about committing; it's well after deployment. Any progress on that front?
Yeah, I mean, like, it's really hard to cover everything because objectives and the scope of every pen test depends on who runs the pen test. But it's limited typically to environment and service that your software is running. Also pretty like smaller scope than the new practice called red teaming, right? But like definitely partially it's coverable by static code analysis, because many findings are related to maybe exposing like either vulnerable libraries, for example. It's easy to use this static code scanning. Another piece of findings typically related to runtime, right? So like it's not always easy to replicate the same environment because like developers deploy in some other way. So, but you definitely have several environments in the way till production, right? So where you deploy as close as possible. And that's where you can do additional tests, like to ensure that, for example, you have the only limited number of ports open, right? Like maybe endpoints, for example, expose only like allow data. For example, like one of the findings that we were getting, like for example, and a bad practice as well, when you like crash internal server error, right? Some request crashes the server, and server actually stack traces like the full trace to the end user, which is kind of bad, because if attacker sees this, right, they know what libraries you're using, what version potentially, and they can go and search what vulnerabilities are there. So this kind of stuff, like we basically maybe more than 50 we were able to cover with static code analysis tools, and the rest, like we added some tests in the deployment pipeline for our like dev and staging environments, right?
Yeah.
Where we did additional checks that like so you test the code, and you also need to test your deployment configuration, right? Because like whatever you test as a dev and you say it works on my computer, it won't work there, because ops will also add their piece, right, to the picture. So you need to do this multi-step project, but I mean, like anyway, you should cover everything. It's like, any bug that is found is better to cover with the test for future, right? Proof. The same with pen test. Like you should cover this with something either on the code level, right, build level, or on the like deployment level, just to make sure that you cover this and it won't come back because somebody just reverted commit or whatever in the future, right?
Yeah, it's very interesting to see how AI will help in this. It'll probably hurt as well, because the attackers also have the AI. So it's not just we have the AI.
Yes, yeah.
But it would be interesting to see if static code analysis, which is always an incomplete step, you can never rely on it fully, on how AI can basically enhance static code analysis so that things like pen testing, the additional value brought by pen testing goes down because the static code analysis is just so good. We're not there yet, but
there are really good examples. Models built by different vendors, IBM in particular as well, where they, for sure, like there are general purpose models that can understand multiple like languages, right? But there are some specific ones that can easily explain you what code is doing, right, and suggest like best practices. But like the main problem there is the trust to the model itself, because like not all the models are built transparently, and and this is, like I mentioned in the very beginning, another surface of attack, right? Because you can put some it's called data poisoning attack, right? So if you feed some bad data to the model, it will start like producing you result that you don't want, right? So you never know what that model was trained on, and potentially it can suggest you the code that will be vulnerable to some issues, right? That's why you should be careful. But I mean, like right now it's like quite easy in our days just to copy paste Java code and ask it to write the Python, and it will do. And also like they can also easily judge the quality of the code and suggest you best practices. But again, you need to be careful with what model you trust, right? And there is also a big community now around AI governance and trustworthiness, right? Probably like everyone also should look for it and see like there is even the score index, right, for the models and their transparency for the consumers to make a decision what they should adopt and use in their development or maybe like business process, right?
Yeah. And like so far we've talked about sort of pre-deployment steps. We haven't really talked about a runtime, like at runtime when the application is actually running, how to observe for security risks, because most observability happens is like people install a tool like Dynatrace, or what was the one that we use, Red Relic or Blue, what was it called?
It was New Relic. It was for performance mostly, but for kind of logs and all that stuff, it was Sumo Logic.
And then we also had App Dynamics, I think, was there for observability. I'm talking just pure observability right now, right? So are there any practices or tools that monitor for threats post deployment? So now we're talking the application's actually running, and now you want to detect for security errors. You've already done your checks, your testing before now the application is live. What are some things to think about in thinking about basically runtime security and preventing attacks during runtime? Is there anything you want to say about that?
Yeah, for sure. I mean, like at runtime, in security space, there are like systems called SIEM, right? Which actually they they aggregate events that happens like in the security landscape, like security logs, audit logs of user access, and so on. Also, they are able to monitor network traffic and connect trace even like the sequence, the flow, right, of access. And they then raise incidents, right, to security operations team, saying like, guys, one of the modern use cases there is user behavior analytics, right? They monitor like some user behavior across the network or like interactions with the system, and they like spot the unusual patterns and they can highlight the risk, right? Or maybe they also typically there are also open threat intelligence feeds and with some markers of malicious activities, right? So these solutions can also highlight. So, for example, like they receive this feed with some recent threats discovered in the wild or in the public, and they say, okay, we see the signature in the log, right? And they help you understand, analyze it, and also take an action, right? So these tools typically have some automation inside. You can create a playbook because many alerts happens like in application world where the ops team receives all the high CPU memory or whatever, right? Or high volume of errors, like HTTP 500 codes, right? Same happens in security, right? They are overwhelmed heavily with the alerts that they're receiving from applications, infrastructure, and network, and they have the automation tools, right, to address this. And also they can later come back to business and application team to help them maybe mitigate the risk, right? So
and like that's where things get sort of complicated because this. So I was checking out. This is from Splunk, right? Acquired by Cisco since and all that. This is a stat from them. So take it for what it's worth. We talked a lot about doing this and that, but 98% of cyber attacks rely on social engineering.
Oh yeah,
to get in.
Exactly.
So we can have all the toolings, all the shift left, all these things, but at the end of the day, it's the human element that ends up causing a lot of these breaches. Any thoughts on that? What can besides just getting your employees with fake phishing attacks, which I tend to pass, I'd say 80% of the time. What can we do here to protect against that? What can technology do? I guess.
Yeah, this example I also had in my mind when you started the discussion was like what we were like caring about more 10 years ago and now. I remember the times when somebody will brute force my password or whatever, and so on. And now just like I will go and get the password from the user, right? Via social engineering or phishing or whatever. But what happens with this regard, like that you mentioned, first of all, pen testing is not enough because it's actually test the environment, right? So that's why we have right now the practice called red teaming, right? Where the guys, they have wider scope and they use close to real attack methodologies, right? Including physical access, like trying to phish the passwords, right? They do it they don't have any limitations. That they are hired by company and they do whatever they want to emulate real life attack. Like try maybe to steal password from user, or maybe use your laptop in Starbucks, right? Or maybe craft the email close to CEO email and see whether you will click their link, right? And they also test the response of the company. So assuming if they're able to breach, they see how your blue team, who protects your enterprise, reacts, and they help actually fine-tune the process. So that's why this practice also is introduced now. And also, we have many more tools available, right? So, for example, the endpoint detection. Was my chair that just decided to drop under myself. So, endpoint detection and response tools, right? That I deployed to devices to help you secure your because users right now after pandemic especially frequently work remote, right? And you literally can be in a Starbucks on public Wi-Fi with somebody sitting in the same network and trying to see what messages you are sending, right? So that's why these tools help first identify such cases and enforce maybe stop the communication, revoke your access from email until you fix this kind of risk, or they may, for example, can enforce like VPN usage or something like that, right? At least there is another log going to a SOC team saying, okay, this guy works from like an unsafe environment, right? And also we need to take like as much as possible accesses from him right now, like remove him from the maybe like mail usage, whatever. Everything should be down, right? So also education, like nobody removes this, right? So you probably know, like every enterprise right now, annual security training. So you learn all the practices, all the security hygiene, right? Like what you should do, like lock screen, So basically, yeah, I mean, like you have these devices, remote devices that can help to actually breach your environment. So you protect them. Now they are endpoints. So basically, your controls are like literally walking on the streets, right? Sometimes in an unprotected network. So you protect them. And also you enhance the security measures in terms of identity access and control, right? So passwords, we all know that we always require to create some really strong passwords. Then we end up with sticker on the display, right? Not to forget the password. That's why now we have we started with MFA, and then even passkeys, right? Passwordless. Also, AI is in the background, so access right now is risk-based, right? The models in the background evaluate is it typical location you access the system or not, right? Like what is your connection? Like is it Wi-Fi unknown or corporate Wi-Fi, right? And based on this, they can make you pass more and more checks before you get access, right?
Yeah. So, sorry. So, I was going to kind of go into what you just said, just to round this off, is authentication mechanisms have sort of changed. And you mentioned passkeys, which Google introduced recently. Obviously, MFA has been around for a while. But one, I want to get your opinion on this one method that I seem to like, and maybe you can tell me why it's a bad idea that I like it. And this is with the magic link. So the magic link, for if you don't know, as the listener, if you don't know what it is, it basically is that you go to a website, and instead of entering a username and password, you just enter your email, and a login link is sent to your email, which you click to log in. So probably the best example of this is Substack. So if you have a Substack account and you want to log in, that's how you end up logging in. Or if you go to maybe there's a few other apps that do this too. Byte Go, which is a famous, pretty popular tech blog, has this one as well. Give me your thoughts on that approach, because basically it's saying we're not going to even maintain your password. We're just going to rely on you to secure your email. So basically, is that a single point of failure? What are your thoughts on that on that approach?
Yeah, I never used this approach. I mean, I guess I saw it in some places, but I'm not widely using it. But I mean, yeah, they definitely let you use your authentication on the mail, right? And then your level of security will basically depend on what kind of measures you enable there. So I think on their side, it's kind of like they have their hands clean, saying that, like, you provide this mail, so like it's up to you now. But then it's still like your responsibility how you have your email secured, right? And whether somebody has easy access to your phone, where the mail can be checked also without potentially biometrics, whatever. Like, so I mean, like, I wouldn't consider this like secure enough, right? At least like for accessing maybe like really sensitive information, right? So maybe like you access the system like with your some private recordings, whatever, they might not be valuable, right, to anyone. But if you want give such level of like trust for similar solution, when you, for example, have the database with credit card, right? Right?
Let me explain my because the way I think about it is that let's assume a lot of people have Gmail accounts, right? And Google is always thinking about security. They're the ones who introduced passkeys recently. So the reason I like this approach is because you're right. You're washing your hands off the problem, but you're washing your hands and deferring the problem to people who are thinking about this all the time. So so if you have this, you're basically, I would argue, protected by the same level of security that Google protects its accounts.
Yeah, but still, like many things there are under your kind of responsibility. You should configure MFA, right? You can use PassKey for Google, right? I don't know, like the guys who try to, like, I don't know, like there might be a way to. I assume they have something in the URL, right? That you click there, like that's kind of confirm that it's a unique URL and you actually click it, right? So there might be some, like, also maybe room for kind of.
No, totally. It has its issues, but I just absolutely love the convenience.
I mean, yeah.
Right.
But
it is.
I don't see even any problem with the passkeys, right? Because they also store in your device securely, and they use your biometrics to confirm that it's actually you, right? So like fingerprint, face, whatever. I also find, and the convenience, I mean, like you don't need to go to your mailbox. You basically just touch your finger and you are in, right? So I mean, like I found for me, I mean, like I used to have these codes on my phone that I have to like type and be quickly enough, right? Then it evolved into like just click approve on your phone, right? After your face is scanned, now it's just like kind of right next to you, right? And also it's additionally based on the depending on the solution, right? Okta, IBM, Verify, or others, right? They now have additional factors in the consideration, right? It can be that easy in the case if you are in the typical location and so on, right? If you are somewhere, maybe like North Korea, just like for some reason, just like today, right? Yesterday, just you were texting with somebody from Toronto, and tomorrow you're in North Korea. They will ask you to, okay, now let's check your password. Let's maybe send your email for confirmation, and then maybe, I don't know, like scan the eye, right?
Yeah. At some point, they're going to ask for a blood test.
Yes.
Let's round this off with some tips. So any a lot of our audience is developers and maybe managers, but any book recommendations, white paper recommendations that you might have to give to people. Maybe think about people who don't generally care about security. Or haven't really cared as much about security, but now because of the changing landscape that we just talked about, need to be more aware of these things. Any tips for those people?
I mean, like books, most developers probably will find boring, right? Like it's too long to read, right? And that's why from this statement comes another one. There are a couple online resources, like literally called Too Long Don't Read, right? For dev, AI, and so on. It's easy to subscribe, and they send like daily or maybe weekly some top practices, some top notices about like attacks that happened, and to stay alert, right? Also for devs, it's like it's probably important to and easy to access and check the OWASP top 10, right? Continuously updated list of top most critical application web server vulnerabilities, right, and problems, and also then they can tune their processes. Like static code analysis tools to look for it, right, and prevent. Also, they can learn like maybe some secure code practice and examples from there. There are a couple of other examples, but they are mostly for security folks, right? Like NIST cybersecurity framework. Like I didn't want to mention this, right? Maybe from the high level, MITRE attack framework can be, at least checked, because they describe all the tactics and techniques that attackers use. Maybe, it's not useful to go deep in that, but at least to know, like how those minds actually work, like attackers, right? What they are looking for. And trying to, and then try just to adopt some like sanity practices, right, in their processes. And in general, there are the secure coding guidelines published by AWS, Microsoft, and other big vendors, right? Where you can also learn like what is considered to be secure and clean code, right? this in general will improve your kind of performance as a developer, and you will learn something.
Yeah. And like, if I can make a recommendation, is to follow Sam Rahman, who was the chief security officer for EPAM LinkedIn. He posts some great content as well, and the links that the resources that Max mentioned, we'll post in the podcast show notes in case you missed them. So, Max, man, thank you for coming on and talking and talking some shop after a bunch of years. It was nice catching up.
Nice to see you. Yeah, it was my first experience, right, in the podcast. So I hope it went well. Yeah,
absolutely. We will definitely have you back once the next cyber attack happens.
Okay. Like ransomware or something like that. Yeah, we'll discuss this in details, right?
Yeah. Thanks, Max.
Great. Thank you. Have a good one.